Assalamualaikum warahmatullahi wabarakatuh. My name is Rendy Suharsono. I'm from Mathematics Education D of Universitas Negeri Padang. In this video, I will explain to you about one topic in mathematics. The topic is permutation and combination. Let's check this out. Permutation and combination. First of all, let's start with permutation. What is permutation? Permutation is arrangement of a number of objects in a defined order. That means, if we look for the arrangement of a number, we must look exactly the order of this number. Next, permutation of S or a permutation of n elements. Let R be a positive integer. By a R permutation of a set S of n elements, we understand a order arrangement of R of the n elements. Next is, if S equals ABC, then the 3-1 permutation of SR A, B, C. The 6-2 permutation of SR AB, AC, BA, BI, CA, CB, and the 6-3 permutation of SR, ABC, ACB, BAC, BCA, CAB, CBA. Next, theorem. For n and r positive integers with permutation nr equals n open bracket n minus 1 close bracket open bracket n minus 2 close bracket triple dot open bracket n minus k plus 1 close bracket equals n factorial over open bracket n minus r close bracket factorial. Next, example. The number of 4-letter words that can be formed by using each of the letters A, B, C, D, E at most once is permutation 5-4 equals 5 factorial over open bracket 5 minus 4 close bracket factorial equals 5 factorial over 1 factorial equals 5 times 4 times 3 times 2 times 1 over 1 equals 120. And if we want to look for the number of 5 letters equals permutation 5-5 equals 5 factorial over open bracket 5 minus 5 close bracket factorial equals 5 factorial over 0 factorial. Remember here, 0 factorial is equals to 1 and equals 5 times 4 times 3 times 2 times 1 over 1 equals 120. Next, permutation cycle. The circular permutation 1, 2, 3, 4, 5, and 6 arise from each of the linear permutations 1, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6, 1, 3, 4, 5, 6, 1, 2, 5, 4, 6, 1, 2, 3, 5, 6, 1, 2, 3, 4, 6, 1, 2, 3, 4, 5. Next, hence, the number of circular permutation of the sixth number equals 6 6 factorial over 6 equals 5 factorial. Next is theorem. The number of circular permutation of a set of n element is given by permutation nr over r equals n factorial over r open bracket n minus r close bracket factorial. In particular, the number of circular permutation of n elements is open bracket n minus 1 factorial. Example, the number of ways to have 12 different markings in a rotation drum is permutation 12 12 over 12 equals 12 factorial over 12 open bracket 12 minus 12 close bracket factorial equals 12 factorial over 12 times 0 factorial. Remember, 0 factorial is equal to 1. Hence, equals to 12 factorial over 12 times 1 equals 12 times 11 factorial over 12 equals to 11 factorial. Or we can use this. Permutation is equal to open bracket n minus 1 close bracket factorial. Permutation is equal to open bracket 12 minus 1 close bracket factorial equals to 11 factorial. Next, permutation multiset. Theorem. Let S be a multiset with object of k different types with finite repetition numbers n1, n2, blah 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 until nk respectively. Let the size of set S be n equal to n1 plus n2 blah 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 until nk. Then the number of permutation of S equals permutation is equal to n factorial over n1 factorial n2 factorial blah 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 until nk factorial. Next, example, the number of permutation of the letter in the word Mississippi is, first of all, let's see the different object with finite repetition number. Letter M, 1 repetition, work as n1. Letter I, 4 repetition, work as n2. Letter S, work at 4 repetition, work as n3. P, letter 2 repetition, work as n4. Hence, the permutation of the letters in the word Mississippi is equal to P equal to 11 factorial over 1 factorial times 4 factorial times 4 factorial times 2 factorial equals 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial all over 1 times 4 times 3 times 2 times 1 times 4 times 2 equals to 34,000 650. Next is combination. Is a selection of a number of objects in any order. That means in a combination, we only select a number of objects in any order. It's a different, like in permutation, that we must be careful with the order of the number object. Next, theorem for r less or equal to n or more or equal to 0, combination nr equals n factorial over r factorial times open bracket n minus r close bracket factorial. Next, example. There are 15 people enrolled in a mathematics course, but exactly 12 attend on any given day. The number of different ways that 12 student can be chosen is combination 15-12 equals 15 factorial over 12 factorial open bracket 15 minus 12 close bracket factorial equals 15 factorial over 12 factorial 3 factorial equals 15 times 14 times 13 times 12 factorial over 12 factorial times 3 times 2 times 1 equals 15 times 14 times 13 over 3 times 2 equals to 455. And you can find this topic in book Introductory Combinatorics 5th edition by Richard A. Brewer. That is my presentation. I think that's all. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.